Hello. So from this video, I'm going to discuss a totally different topic. Like so far, we learned how to calculate and some properties of the expected value or the average. But now I will discuss shortcomings of the average. What you have to be careful when you use the average. Like I explained as if like we have to maximize expected utility when we make a decision. We should use the average, but that is not right. So average is the most common choice, and so if there is no other reason, then use average to make your decision. But always there is potential problems if you rely too much on the average. So I will explain in what case, in what circumstances, the average could be problematic. I will start with census data from 2010. So it's state population data, and in million, so. California is the biggest dominant, the biggest, absolutely the biggest state in the United States, and Texas is the second biggest. Maybe since 2010, I think Texas increased a lot, and maybe California also increased a lot. So New York and Florida are following the two. So these are pretty much the top four, most populated states in the United States, right? You know. So then I will take them as data and would like to calculate the mean. The mean state population is here, 6.05 million, which lies in this interval between 6 and 7, more close to 6. So you can imagine it is exactly between at the beginning of 6 to 7 interval. But so if you take this as the mean, and I said the mean is a representative number, it's somewhere in the center of the observations. But there are only 17 states that have larger population than the mean. 34 states are smaller than the mean, right? So it's like 2/3 and only 1/3 of the states are above, right? So I included DC as a state. So anyhow, the point here is the mean is not the center. It's more toward the larger side. Why? There are more states below than above the mean. So the mean is unbalanced, which could be a problem in some special cases. So we are going to introduce a new measure of location that is balanced. That is to divide the sample exactly in half. I'd like to find exactly the middle, the center of the data. That is the median, right? It's pretty intuitive. In our case, there are 51 states. Then you can divide the data by into half and half. If you choose the 26th largest state, that is Kentucky. So if you choose Kentucky as the middle, Kentucky is exactly middle because 25 are larger than Kentucky and 25 are smaller than Kentucky. So perfectly balanced, right? So and Kentucky's population is 4.34. So it is the median. It divides the data exactly half and half. We define this as the median, and we usually denote it as median of x or MED of x, random variable x. So if you input x, then the output is its center. Okay? Then median is 4.34. Kentucky is here. It is different, right? Different from the mean. Usually they are very different, right? So we will study why they are different and what is the problem. Before doing that, I will show you how to calculate the median first. But remember, it's similar to calculating the average. You have to think about the format of the information. There are two different formats. One is raw data, and the other is the probability distribution table. So raw data, I will explain one by one. When you have raw data, it is pretty simple because what you have to do is rearrange the observed numbers in descending order or in the ascending order, no matter what, and choose the middle one. That's it. As simple as that. So in this example, I only took Pacific states, right? And then I reorder them. The biggest is California, the smallest is Alaska, right? So if you order 5 states in this way, then I choose the middle one, which is Oregon, right? Oregon is the middle state. 2 states are smaller than Oregon and 2 states are larger, so Oregon is the median. The answer is 3.83. Meanwhile, if you calculate the mean based on these 5 observations, you are going to get nearly 10 million. So the mean is nearly 3 times larger than the median. So again, it's a huge difference. Now, this is easy when you have odd number of observations. But when you have even number of observations, like New England states, I already ordered the states in ascending order. So there are 6 states in New England region, and there is no middle because it's even number, right? And then in this case, I am going to take the 2 states in the middle and take their average, right? So New Hampshire and Maine are the middle states, and I will find the middle of the middle, right? So the median is 1.325, right? So when you have even number of observations, it requires additional step, but not a big deal. Okay, and still in this case, the mean is 2.4, which is again different and larger than the median, right? So of course, when you have a larger number of observations, it is not easy to order them by hand. But of course, you're going to use Excel or some program, so they can do it easily. So I don't worry about that. Excel can do it pretty simple. Sort the observations, or there should be function. Um, but now the difference is we are going to use the probability distribution table to calculate the median. Previously, this is how you calculate the median from raw data, but now we are going to use the probability distribution. Then it's much more complicated because the definition goes like we hope to have probability that the random variable being smaller than median is exactly half 50%, and also the probability greater than the median is exactly 50%, if possible. But later you are going to see an example. These are not easy to satisfy. So in some cases you cannot exactly cut half and half. So we relax this condition to this way. So probability x is smaller than or equal to median is at least 50%, and the other side is also at least 50%. These inequalities are possible because equal to median is included in both cases. Both events include equality, so you may include both can be greater than 50%. So you will see what I mean by these two. Now I will think about a new example. Suppose that you have a probability distribution table of number of pets in a household, right? Suppose that there are 5 possible outcomes, and 28% of households have 0 pet, and 21% have 1, 19% have 2 pets, 17% have 3 pets, and 15% have 4 pets. Of course, the data is not real. I just made up the number for simplicity. Here, let me find the median. It's not easy. Like it can be 2 or 1 or I don't know. What you have to do here is, so of course you start from the probability for each outcome, and then what you need to do is to calculate the cumulative distribution function, right? So, cumulative distribution is the probability smaller than or equal to a certain value. So you accumulate probability from the smallest, like this. For example, at 0, the cumulative probability is 28% because there is nothing to accumulate. But if you move to 1, cumulative probability up to 1 is 28 plus 21. So calculate from the smallest possible outcome up to 1, right? Include these two. And at value 2, you accumulate 3 probabilities up to like 28 plus 21 plus 19. Like that, you are adding one more probability as you move to the right. And in the end, the biggest outcome will have all probability, so it should be 100%. That is cumulative probability, and we call this cumulative distribution function, which is CDF. And this is also very important in a later chapter. You are going to see this again in chapter 6 or 7. So remember that this is very important, not only for the median, but in general statistics. Okay, so anyhow, it is intuitive to see this. Like, for example, if you input 3, then cumulative distribution function will return the probability up to 3, from 0 to 3. Okay, so accumulate probability. And so you get, like, you go like this, right? You see, you keep adding the probabilities. And then remember, what we want is we would like to choose one number. Median would be one of these 5 numbers, 0, 1, 2, 3, or 4. If you put one number here, that should satisfy these two inequalities at the same time. What is that? Like, you have to, like, 1, like if you plug in 0, like probability smaller than 0 is only 28%. This inequality does not satisfy. 1 does not satisfy the first inequality either. You have to go to 2. So if you plug in 2 in the median, if you believe the median is 2, then the first inequality will be satisfied. So first inequality will be satisfied by these 3 values. They are candidates. But to satisfy the second one, you have to count probability from the largest again. From the largest back to this, like, so probability x greater than 2 or equal to 2 includes, this probability will include 19 plus 17 plus 15%, right? So if you calculate that, it is 51%, right? So if you plug in 2 into the median, you are going to get both inequalities. So simply speaking, you have to find the smallest value that satisfies the first inequality. That is the rule. Okay? So it is not the nearest value. One tricky thing here is it may look like 1 is closer to the center. No, we don't choose it as the median. The median should be the one that satisfies both inequalities greater than the minimum above 50%. Minimum value with CDF greater than at least 50%. Okay, so it's tricky, but but intuitive, right? I believe you see why 2 becomes the median. Okay, so try this by yourself and get the median based on from this probability distribution table. Calculate the cumulative distribution function and then turn that into the median. Okay, so I will stop the video here and leave it to you and continue to the next video after finishing this question. See you then.